We're talking about radical.
So, if remember before the holiday, when I would say radical 2 times radical 2 is radical 4, which is
Plus
2.
4.
2.
which is 2. Good trip. So, what do you think we could do to the denominator here, radical 3, that would make that
Plus
radical,
Times it by 3.
or radical 3?
You can
Yes.
only have
So,
squares at the bottom.
no, no. All we're wanting to do is remove the radical sign. We can have any number down there. I just want the radical sign to go away. So if I have a radical 12, I could multiply it by radical 12, and we're going to be back to 12 without the radical mark. So because like radical 4 times radical 4 gives you a perfect square of radical 16, which can then be broken down to 4 or simplified to 4. So whatever's in the denom, that's what we're going to multiply itself by as far as radical goes. Now there's that rule you learned back in 2nd or 3rd grade. If you do something to the denominator, you got to do it to the numerator. So in this case for number 1, we're going to be multiplying, good, it's up here, radical 3 by what number?
Radical 3.
That means we're going to multiply the radical 2 by radical 3. So, everything's inside a radical at this point. So we multiply the radicals together. Radical 2 times radical 3 gives us
Radical 6.
radical 6. And radical 3 times radical 3 is radical 9, which is,
3.
there we go. Final answer. I know a lot of times when you see 6 over 3, you think, oh, I've got to simplify. But the radical, the 6 is inside the radical, the 3 is not inside the radical, so they can't participate at all. If we had a number sitting outside the radical 6 that, I don't know, maybe it was 9, we could simplify the 9 and the 3, but not the radical 6. Sir?
So we can't just get any number we want and times it.
Well, if you did that, you would possibly end up still having a radical in the denom.
Yeah.
And we want that's the whole purpose of this, is to remove the radical sign for the
That's
denom.
it? That's all we just got.
Yeah, that's all we're doing.
Wait, I don't. Then why doesn't the bottom change?
There's a catch.
It did. It became a 3. Because remember, any number, anytime you multiply a radical by itself, it's the same number, just no radical sign. And guys, this is something I want to make sure you understand. When we have the number 3, like we have right here, that's a 3. Like 1, 2, 3, 3 people. If I have radical 3, that is really 1.732. They are not the same thing. Okay? Sir?
I just don't understand how radicals even came to be a radical. How did people just come up with radicals?
Wait, Dr. Graham.
What's the point of a radical? I just don't understand.
You will use radicals through anytime you're in a science field. I've done a little bit of looking into it, and most science fields have radicals involved. All right, we're going to move on with this because we're going to teach right to the bell. Yes.
What if, the denominator isn't a perfect square? Does it matter?
Well, radical 3 is not a perfect square. So what we do is make it a perfect square by multiplying it by itself.
Radical 9.
And gotten radical 9, which then becomes 3. So we're back.
If the numerator is
We're going to you're working further, just hang out.
I actually have a good question. So, the denominator, do you have to times it by its number? Can it be any number?
All right, gosh, I feel like we're on a hamster wheel. Have we not had this discussion, Carr?
Yeah, that's what Carl was saying. He said,
Uh-huh.
just said that.
Just
We
it's
just-
easier just to do that letter because it.
All right, if I said radical
So it's always
2,
a perfect
just
square.
listen, if I said radical 2 times radical 4, I get radical 8. Well, I still would have a radical. Radical 2 times radical 1. Radical 2 comes radical 3. The only way to really be sure you pick the right one is to say radical 2 by itself. And then you get A
two.
perfect square. Uh-huh.
So doing radical 2 times radical 2, you get 2. And then do you multiply the radical 2 times 5?
No, you multiply the radical 5 times radical 2. Whatever you multiply the denominator, we're talking about number 2. You whatever the denominator is, that's the driving force. Whatever it is, that's what you're multiplying by. And you know the rule of fractions. Whatever you do to one numerator, you got to do the denominator.
So it'd be radical 10 over 2, which then would I not reduce it?
Perfect.
Do you reduce it?
Radical 10, you would think, could break down.
No, but like, do you not reduce it because it's divided by 2?
All right.
See what I'm saying?
I do see what you're saying, but let me write it up here. Radical 10 over 2. Perfect answer. Radical 10 is a radical. 2 is not. They can't cross over. It's like a barrier wall. Outside numbers work with outside numbers. Inside radicals work with inside radicals. 10 and 2 share factors, but that's not 10.
Which radical?
That's, let me go to my handy dandy calculator. That is really 3.16 over 2.
I thought we just rounded it to 30.
Yeah, we just round
There you go. All right, what did you get for, and let me say this. There are rules. You know how I'm always saying, first thing, look for the greatest common factor. You know, say that all the time. In here, what I want you to look for first, if they're both, look at the radicals and see if you can simplify just the radical numbers. If there are outside numbers, see if you can simplify them. Once you've simplified, look to see if there are any perfect squares.
So first step, simplify.
So first step, like number 3,
Would be
radical 9 over radical 6, do they
Simplify
share,
the
do they share factors?
Yes.
What do they share?
3.
3. We're going to divide both by 3. So that gives us radical 3 over radical 2. Now what am I going to multiply
Why would
by?
it be radical? Why would it be radical 3?
Because I'm dividing by 3. I'm dividing by the greatest common factor.
Wait, whoa.
6 over
First thing you do is to see if you can simplify your fraction.
radical 6 over 2.
What?
And so they both, 9 and 6 share factors. I know 9 is a perfect
I
square.
think it would just come out as just regular 3. That's what I'm saying.
I got you. But the process, it's like PEMDAS. You got to follow an order. You're going to see if you can simplify first. Removing greatest common factors. I know. I would like to say, 3 over radical 6 and then multiply, but that doesn't work. So you set it up that way, then look to see if there are any perfect squares, and they're not. Now we're going to multiply everything by what? Radical 2. And what's the answer? Radical 6 over 2. They are not both radicals, so you can't simplify any further.
So if you multiplied by radical 6, would it give you the wrong answer?
No, you would just have more work to do.
So like the radical 54, you'd have to simplify that.
Mhm.
That's what I did.
And did you get radical 6 over 2? But you'd end up canceling out some numbers, and yeah. This just makes it a little less big numbers to work with.
Wait, Doctor, I just don't get like how on the other one you're doing just multiply by radical 3. So why would you go to this one by radical 6?
You can. Like Kevin said, ooh, I multiplied by radical 6. But you got the same answer. All we're doing here was seeing if we could simplify the numbers. Like, when you have fractions, your rule for multiplying fractions is to see if you can simplify, like cancel out first, so that you're not multiplying with big numbers. This is just seeing if you can simplify so you're not having to multiply with big numbers. Because when Kevin worked it, he ended up with numbers outside the radicals, and then he had to simplify further. We took it to where we got all the way here without having to do that step.
Wait, Kevin, what did you get like right after you did radicals times radical 6? What did you get?
Radical 54,
Oh, because you have to
Over
I see what you're
6.
saying now.
and then when you break down 54, that gives us what?
Oh, I see where you're
9 times 6, So we have 3 radical 6 all over 6. And then we had to remember to simplify. And you're back to radical 6 over 2. It was just a longer version. You do number 4. Several of you are hanging, so I'm assuming you have it. What you got?
One, just radical 2.
Radical 2.
Huh? I got 2 radical 2 over 2.
Right. You got this, 2 radical 2 over 2.
Oh, you gotta
Simplify.
Ah.
Yeah, hurt you every time.
Give me that.
All righty.
So you simplify it, you get.
Radical 2.
Wait, how did you work that? I'm confused now.
All right, so number 4, what did you multiply numerator and denominator by?
Radical 2.
Radical 2. So you ended up with 2 radical 2 in the numerator. And then the denominator is radical 2 times radical 2, which is radical 4, which is 2. But the outside 2's cancel out, which leave you with radical 2.
I did not cancel out.
But do you see, you got to the 2 radical 2 over 2? Okay. All right. Ooh, number 6. Can you simplify?
No.
First question. Are there any, and the answer is no. Are there any perfect squares?
Yes.
So what's the final answer?
Radical 5 over.
Radical 5 over 4. 16's a perfect square.
If there's a perfect square in the numerator, would you do the same thing?
But ask yourself if you can simplify first. Simplify first, then look for those.
Wait, but isn't it 2 times 2 is 4, so how's 4? Perfect square.
Because what is
Oh,
the
and then
16? It's out of it. It's outside of the radical by the time you get to 4, Kevin.
Just 2 perfect squares, just no radical.
Wait, say that one more time.
Radical number 7.
Oh, what'd you get?
2 over 3.
2 over 3? Everything was perfect. That one, yeah, that's lovely. The first thing you asked, though, do 4 and 9 share anything? No, but are they perfect squares? All right, number 8. First thing we ask, can we simplify? What do you get? What do they share, 3 and 12?
1 over 4.
They-
Sure, 3.
Their share of 3, we're going to divide by 3. So we get radical 1 over radical 4. So what's the final answer?
Radical 1 over 2.
No, almost. Radical 1's a perfect square. 1 times
1 over
1.
2.
1 over 2. Yep. That 1 throws, yeah,
Wait, how'd you do that?
it's a secret. You divide by 3. First thing you ask, so you got radical 1 over radical 4? All right, radical 4, perfect square.
just do 2,
And then radical 1 is also a perfect square.
so you don't have to mess with the 1.
Well, it's 1 over 1. 1 times 1 is 1, so it's a perfect square, so it comes out.
Okay.
Number 9. Mm-mm. Can we simplify? Remember to simplify first, then look for radicals. Perfect squares, I mean. Can we?
Can you?
Yeah,
They're both even.
2.
We on 9.
We are.
Radical 3 over 2.
Yes, sir. Radical 3 over 2. So we simplify by 2. And we have radical 3 over radical 4. And you know 4 is a perfect square, so radical 3 over 2.
I'm a little bit confused, so I got radical 3 over radical 4.
Uh-huh.
Now what do I do?
Perfect square. Are there any perfect
What I'm
squares?
asking is what do I times it? Do I times it by 2?
Wait, all right, wait just a second. Harper, you got here. Radical 3, you simplified. Then your question is, are there any perfect squares?
Well, I know that 2 is the perfect square for 4, but what do I times it by?
Nothing. You just...
Oh,
And
that's
when
what I
you
like.
change the 4, radical 4 to a 2, That solves the problem. Now there are no radicals in the
So I
denom.
don't even have to mess with the 3.
But, and the only reason we would mess with it is if we still had a radical in the denom. Our whole purpose is to get rid of denom radicals. All right, 12. You work it.
Radical 15.
He's so fast. Excellent.
Wait, what?
What is it, Kevin?
Radical 15.
Radical 15. Kevin's got this. All right, so what did you multiply by, Kevin?
3.
Radical 3. And that means the denominator is a 3. And the numerator was 3 radical 15. And then the 3's cancel out. And you're left with radical 15.
I'm still confused on number 9. Like how you simplify it.
All right, we had so you knew first thing you do is look for how to simplify. So that they shared a 2. Next question, are there any perfect squares? And that's 4.
Oh,
And then once that's, once you have a denom that doesn't have a radical, then
You're done.
check and make sure that the radical in the numerator is simplified. Like it's not like radical 20 where you could break it down.
Okay.
But yes. All right. Going to the next page, we have some interesting and entertaining prospects here. Oh, it didn't get bigger.
Negative.
All right, the negative sign, it just travels. It's like no big deal. Your answer will be a negative fraction. So don't let that throw you. Figure out the answer though for 13. Oh, wait, back up. I think there's one thing I did not show you. Look back at 11. Whoops. All right, 11.
What do we do when we get 2 regular numbers on the bottom?
Multiply that.
Multiply?
So let me talk to you, Wake Car, if you're working 11. This is, the denom is 4 radical 3. What operation is that representing? Addition, subtraction, multiplication, or division?
Division.
Well, the whole fraction is, but when you have just a radical,
Multiplication.
4 radical 3 means like we would take 4 and find the perfect square, which is 16, and multiply it by 3, and we'd be underneath the house. Radical 48. So, when you are removing the radical and it's a multiplication problem, you only work with the radical. The 4, the number outside the radical just hangs out until you've removed the radical sign. So in other words, from number 11, we're going to be multiplying the numerator and the denominator only by radical 3, not 4 radical 3. Okay? And then radical 3 times radical 3 is radical 9, which is what number? So the denominator is really 12 because 4 times whatever comes out, which is 3.
And then the top 15 radical.
12 and then radical 15. Because we said, 5 times 3. And I know 15 and 12 share factors if they were just pure numbers. One's a radical, one is not. So we
How do we
can't
get
go
12
any
with-
further.
Do we get 12 with no?
We said radical 3 times radical 3 gives us 3.
3 times 4 is 12.
3 times 4. Go back to the number left
We
behind
leave it like that.
and leave it unless we came up with a number in the numerator that could be broken down further and we could simplify. Vivian, are you okay? Okay. Now to the back page. Oops. So what are you going to multiply 13 by?
5.
Radical 5. Hop on that.
Negative radical 5 over 15.
Oh, look, we had to give Kevin a little help there. Thank you, Carr. Negative. Very good. Negative radical 5 over 15. All right. Look at number 15. Remember when we worked with exponents and we were dividing?
Makes me love life.
I know. What do we do with exponents when
Subtract.
yes, we subtract those that are alike. So 5k, this k under the radical, what is its exponent? It doesn't, we don't see it, but we know it's a 1. So 1 and minus 3. So we're gonna, which do we look? Yes, it's gonna be a 2
On the bottom,
in the bottom. What happens to the numerator k?
it goes away.
Goes away.
Oh wait, how is it not negative? Because 1 minus 3 would be negative 2. Not how it works, buddy.
That's not how. So what we're gonna do, we will remove the 1 in our k. So we're gonna have 5 radical 5 all over 3k squared. All right, before we do anything else, our next step, are you good with how we got where we are? Okay. Anything, can we simplify anything number-wise? And are there any perfect squares?
K squared.
The k squared.
Where did the K on the 5 go?
This was like having k over k to the third. And this went away, like became a 1, and this became k squared. It's like 1 minus 3. Okay? Does that ring a bell? All right. And what we said really was go to the larger exponent and subtract from there. Like 3 minus 1 gives us 2.
Okay.
And remember that?
Yeah.
All right. So, y'all have agreed that k squared is a perfect square, so I'm throwing it out first. And we have in the denominator just radical 3, and we have 5 radical 5 in the numerator. Is everybody good to this point? You finish it. Kevin, what'd you get?
Oh, wait, no, I got lost.
Oh,
I'm not hating.
are y'all good with getting to 5 radical 5 over k radical 3?
I want to finish it.
Who said no? Like Harper. All right. You know how we subtract exponents when we're dividing. So 3 minus 1 gives us 2. And that, we removed that k to the first. It's gone. So k squared is a perfect square.
Oh, so you gotta take it
So
out.
it comes out as a k.
That's
And
what
we're
I was
left with 5 radical 5 over k radical 3. Car.
So you know how like we have to multiply to get the non-radical version?
Mm-hmm.
Do we multiply the k squared with it?
We've removed the k squared. We're over here now.
How do
So-
we remove
What, car?
how do we remove the k squared?
K squared is a perfect square. All exponents that
Oh, we
are
got
even.
k.
We have a k outside. So we're only going to be multiplying by radical 3 to solve.
Yeah, I got you.
So what did y'all get?
5 radical 15, 3k.
5 radical 15 over 3k. Fabulous. All righty.
Who's gonna be back?
Now, let me say this before we go any further on this one. When you get there, then double check that none of the outside numbers can be simplified. In this case, 5 and 3 cannot, but just be sure that they can't. We're going to jump down to number 18. It is so fun.
Me.
It takes some listening and thinking. All right. First, look at the numbers inside the radical. 3 and 5. Can they be simplified? No. All right. Then we look at the variables. So we have u's. And right here in the top is a 1. So what is 4 minus 1? 3. What happens to that numerator u?
Gone.
Gone. Okay. So let me fix that part. So we have a 3. I'm coming back to talk about the v in a second. And we have a 5 radical 5 u to the third. Everybody good so far? Now, let's look at the, oopsie daisy. Now look at the v's. What is the exponent and where does it live? Numerator or denominator for the v?
Denominator,
Denominator, and what is it?
b squared.
V squared. Go to the larger number, which is the 4, and that's where it will live. 4 minus 2 in your exponents is 2. So we have v squared.
B squared.
And we don't have anything, the v and the u have both left the numerator. Make sense so far?
So, now we gotta put them out.
Almost. Or, yes,
The
or
the U stays.
the u stays, but what about the v?
It goes
Perfect square. Where does it go?
out.
With
to 5.
the 5. So now we have 5v, not v squared, just v, radical 5u to the third over radical 3. So what are we going to multiply by to remove the radical?
5u3.
5u3.
We have a question.
Sir,
Why wouldn't you do the, V?
we got to simplify first. You probably could, but I think it'll make it a little easier if we just don't yet. All right. Oh, why don't we put it? Oh, I know what you're at. No, in this, I'm not going to ask that you
Thank
do.
you, Lord, because I just did that. You see.
Yeah, no. I now know what I misunderstood your question. I thought, why didn't we simplify the u further?
Wait,
No, we
why?
won't have to put it in absolute value
Why don't
bars
we just take the v out again?
because it's a v squared. Perfect square.
Oh, yeah.
All right, so we're going to multiply everything. I'm going to change color.
Wait, so the U and V touching?
No, there's no touching.
So they're basically just separated, just like the other U and V with 4s?
Do we have to FOIL the 5u3, 5u3?
They're not binomials.
So it's just like.
Not yet.
25u to the 9th.
All right, so when we have 25u to the 9th,
Oh, it comes out as 3.
comes out as 5u to the third.
What?
And then do you put the v?
Mm-hmm. 5u to the third multiplied by itself comes back to 5u to the third. So now we have 5v times 5u to the third. What does that give us? 25.
25 U to the third V.
Yes. So our denominator is 25 u to the third v. Okay? Now, numerator.
Why did we have to times those? Why couldn't we have just left it 5v, 5v?
Because you don't. You simplify. You got to put everything together. That would be like leaving like terms not together. What is the numerator?
Radical 15.
v.
Radical 15 u to the third. All right. Anything under that radical that we could break out?
The U.
The u.
Wow.
Because it's u squared times u. So how does it come out?
The u squared comes out and the u stays.
So that means I'm going to change color one more time as a green. We're going to have, I'm writing all over the place. So we come here and now we're going over here. And we're going to have 5. Wait, my bad. Erase. We have u radical 15u all over 25 u to the third v. Are we through?
No.
No. Why not?
Because you don't
Instead
want
of
to be done.
delete, like, get rid of the U. Get rid of the U.
Because I don't want to be done.
I thought we
So
were
it's
done.
U to
but,
the
like,
2. on
The
bottom,
U's
and then
come
U
out.
gone.
So this u is out of here, and this u becomes a 2. This is all
I don't
18.
even know what I don't even know what color we're on right now.
We're on green.
Whole color wheel.
I know. There's our
I
answer.
swear we had that like
15, no we didn't.
ago.
15, radical 15u over 25u squared v.
I thought the U squared were on the outside of the 15.
Car.
hmm It did come out.
I don't see it.
You know, first it wasn't that bad.
It was a u to the third. And then it came out here as u squared, which means it's a u. you had u to the third under the radical, right here.
Yes,
And then that means u squared times u
and u squared comes out.
as a u, right here.
Okay,
And this was u to the cube.
okay.
So they cancel out, simplify, and that goes away, and that becomes u squared. And we're done. That one's a doozy.
Why do you say
Let's make my
every
brain
round like
hurt.
those?
Can we please not have that? Like,
She goes,
I
and
still
then
saw
you
her
guys over
in
here,
the
and then you halves, we times it again. We're done.
Okay, you work 22. What are we gonna multiply by for 22? Wait till the next page.
I always,
11.
I always think it's,
understood one.
I always think it's easy because like there's always.
It's easy like at the beginning, then we like flip the page and it's like
Said
impossible.
understood one.
I love it, but it's understood radical 11.
You said understood one.
Radical 11 times radical 11 gives us what number? 11
Is that the answer?
for the denominator. Then we are going to distribute radical 11 across both clumpies. Shh. Remember, we're multiplying. You know, when you whatever you do to the denominator, you do to the numerator, and vice versa. Radical 11 times 3 is what?
Oh,
3, no. Outside, inside. 3 radical 11.
goodness.
I think I actually got this one.
And then what's radical 2 times radical 11?
Oh,
22,
22?
which is 11.
Which, that's not a perfect square. So she's done.
So close.
that's it.
That's
Wait,
it.
No. You're supposed to times the 3 and the 11. Not how you work it.
We did. We got 3 radical 11.
So close yet so far.
How did the
All right.
11
If
get
you will, how did the what?
Never mind.
If you will pass back the sheets that the first people are holding.
Should have.
We're so not done.
We
Reynolds, you have the papers for the ladies in the back whenever it gets there.
Dividing radicals, 2 notes.
I know.
I'm trying to I'm only gonna do the evens.
Uh-huh.
Yeah.
So does that mean the others are homework?
It literally says it.
All right. This time, we are adding and subtracting radicals. This time, I want you to hear this first little explanation, and I promise you, this sheet's, to me, easier. I know, everybody, look at how much longer we have. We have 12 minutes. Yes.
Uh-oh.
No, you can't go anywhere.
No, can we start working these at the beginning? Because I feel like at the last 10 minutes, it's like you pass out that final sheet and it's just like
This is.
final ball.
I say we go.
No, which,
Okay.
she always
All right.
does.
So, what is the whole purpose in working these? Is to remove the what?
Radical.
The radical from the denom. We've been working with multiplication problems, which meant we took the radical only. This time, addition and subtraction, they are connected. They're like, holding on to each other. You can't separate addition and subtraction parts. So do you remember when we were multiplying and we were dealing with the difference of perfect squares?
No.
How we had x plus 2, x minus 2?
Oh my gosh.
Uh-huh. So,
I don't.
that is kind of the same premise. We
Is that the
want
first one?
perfect squares. We're trying to achieve perfect squares in the denom. If we use the same operation, like times radical 2 plus 4, we will end up with a middle number.
So like,
But if we use opposite signs, your outer and your inner will become 0. And that's what we're looking for. So what you're going to multiply by is called the conjugate of the denominator, which means you're taking this, and instead of multiplying by addition, you multiply by subtraction. And then like this number 3, it's subtraction. You don't change any of the number, like the -4 stays -4, but you'll multiply by addition. So and then you use the same with the numerator. So let me show you super quick. If we had radical 2 plus 4, and we multiplied that by radical 2 plus 4, we're going to FOIL. The radical 2's would give us, oh, thank you. The radical 2's would give us a 2. The outer would give us 4 radical 2. The inner would give us 4 radical 2. And the last would give us 16. And we would have 18 plus 8 radical 2. Did we remove the radical?
Or, hold on.
You don't have to write this down.
No, you
I'm
didn't.
showing you
No,
why.
Oh.
Wait,
Sorry.
is that?
No,
I don't
you
even
Miss,
understand
no,
where we're
stop
going.
and listen. I was telling you had to use opposite signs, and here is why.
Is that like times, like you're just separate again?
If you don't use opposite signs, your radical doesn't go away. So, that is why we use
Negative.
the conjugate. Exactly. So what we're going to do is multiply by radical 2 minus 4.
So we have to do
So
it on
are
the
we
top two,
boiling?
right?
And yes, we're foiling. And yes, we multiply the numerator. So, here we go. Radical 2 times radical 2 gives me what number?
2.
2. Our outer and inner give us negative 4 radical 2, positive 4 radical 2, which is 0. Then what's your last number?
Negative 6.
Negative 16. What's 2 minus 16?
Negative 14.
So we have negative 14 as our denom. All right. We distribute the 4 from the numerator. What's 4 times radical 2? 4 radical 2. And then 4 times negative 4.
Negative 16.
Okay. Now it's kind of like the Three Musketeer doodad. Do all 3 of these share factors? Yes, the 4, the 16, and the 14. They share a 2. But I need my denominator to be a positive number. So instead of dividing by 2, we're going to divide by negative 2. Or simplify by negative 2.
So our denominator can't be
Negative.
Or
We want it to be positive. So this means we would have negative 2 radical 2 plus 8 all over 7. And the negative 2, the 7, and the 8 would have to share factors in order to simplify further. And these aren't like terms. The numerator is not like terms. All right, where did I lose you?
She
When you passed
divided.
out this paper.
She divided everything. by
I understand
2.
what you did,
Okay.
and then you simplify.
Yeah.
Yeah, that's simplified. Yeah.
All right,
This is
number
just
5.
boring.
You do 5.
Yeah. What's the first step?
Figure out what the conjugate is. Like your numerator is plus.
Can we have it different times by the numerator and different times by the denominator? Like, can we time something different on the
No.
numerator than the denominator?
No. Same, or it will change the proportion of the fraction.
So it all has to be different.
Actually, y'all do 3. Do 3.
No, I understand. I just was wondering.
Okay.
Are we still doing number 2
Okay.
or 3?
We need to do one that's addition, but it's okay. You'll be all right.
That's number 7.
I meant where you multiply by addition. This one you're multiplying by subtraction. But we'll do number 9. So guys, do you have the answer for 5?
Not yet.
Wow, I've already
It's gonna take
We changed it. We're back to 5. We throw you all over the place because we're going to do 9 as well. So what are you going to multiply number 5 by?
Radical 2 minus radical 3.
Good. Both places. Guys, stop talking.
But I'm just like,
So you're going to be foiling all over the place.
hey,
Shh. That crew, I don't want to call names. Stop. What is the denom for number 5?
radical 6.
radical 3 times radical 3 is radical 9, which is 3. What's the denom?
Radical 3 times radical 3, so 3. And then it's minus 6.
1. -1.
So our denominator is 1, positive 1.
That's it?
Well, that's the denominator.
Why positive? Because.
3 minus 2. Because your 2 will be negative. The 2 and the negative 2. So then we'll have radical 6 minus 2 minus 3 plus radical 6 when I FOILed. So what's my final answer? Put your like terms together.
-5
Uh-huh.
over 1.
It's -5 plus.
-5.
2 radical 6.
2 radical 6.
So 2 radical 6
Minus 5
minus 5
over 1.
over 1. All right, do number 9. You've got 3 minutes for the bell, I believe.
More than 3 minutes.
4 minutes,
Maybe 4.
maybe 5.
Maybe 5.
Y'all got time. What are you going to multiply 9 by, the denominator?
2 minus 3.
2 plus 3.
2 plus 3 radical 2.
Wait, what question are we on?
9. I didn't move it up.
4.
What's the denom?
-3. Is it -3?
Yes. No, it's not.
3.
Because it's 3.
Is it 10?
Oops. So 2 times 2, that is 4. And then 3, but then that's going to be,
I forgot-
9. My bad.
I forgot to take the.
I also kept the 3 as a radical. I was going to say, that's not the right number. 9 times, 'cause it should be 18. So 4 minus 18.
It's 22 plus.
4 minus 18.
-14.
It's is it 14 plus 36, right? 2 over that.
So you should have 4 plus 6 radical 2 all over -14. But they share a what?
2.
Car, you would have said your last is -3 times 3 is -9. And then
Radical 2.
2 times, that's 4, which is radical, which is 2. So that's 18. And so 4 minus 18 would give us the 14. And then you divide by -2.
Foil it. I think that's what it is. That's what it is.
Is that our homework?
Homework is going to be the evens,
On that page,
So-
both, the whole thing.
So 10
2 pages
problems?
of even.
10 problems. So -2 minus 3 radical 2 all over 7.
Are we gonna use this in the science field?